We good to go? All right. Hi, everybody. My name is John Askew, and I'm talking about how to upgrade your vulnerability assessment. Like I said, my name is John. I am a senior security consultant with SDG Blue, which is a local information technology and security company. If you want to learn more about the company, sdgblue.com. I've done quite a few security assessments. I've been doing security consulting for over 7 years now. Probably done hundreds of different types of security assessments, and stuff I'm talking about today is kind of come out of a lot of that experience. I've got kids who kept me up most of the last night, so I'm running on about 2 hours of sleep. If I just stop talking in the middle of something, just drag me off stage. So what am I going to talk about today? First of all, why I think what I'm talking about is relevant and why I'm talking about it. Vulnerability assessments, something that's been being done for many, many years, and this has been around for 15 years or more. So there's a lot that has been done in this field, but still today we see a lot of vulnerability assessments that are done that have a lot of room for improvement. We'll just say that. There's lots of gaps in certain areas that I think are ripe for some quick wins and some improvements. So I think I hope to highlight a few of those areas today in the next 20 minutes or so. The question that I want to answer is, how can you upgrade your vulnerability assessment? And I think that comes back to a couple different components of a vulnerability assessment. Improving our data collection, how we get the data that we're using for the analysis, improving the way that we do the analysis, and then the ultimate goal of any vulnerability assessment is communication and reporting. So improving the process of transferring that information to whoever the important party is there is critical as well. And then after I talk about all that, I just want to wrap up with a big picture of what this all means to me at a high level. I am releasing a tool along with this talk. Guido is it started out as a set of scripts that I wrote kind of in my spare time that would parse different vulnerability scan results and look for certain types of information from them. And so I've kind of brought that all together, or attempting to bring that all together in a unified toolkit. It's available for download now. You can do a git clone of the Bitbucket repo. You can even do a pip install if you have Python installed. It should work on Python 2.7, Python 2 or Python 3, the latest versions. Although there's a bug that I just fixed on the version 3, so that's in the Bitbucket repo, but not in the Python package index package just yet. It is what I would consider very much alpha software. It's got a lot of rough edges, not polished at all. It scratches a lot of itches for me. It fills a lot of needs that I've had, but there's a lot left to do with it. There's a lot of things that just plain out don't work right now, so just be aware of that if you play around with it. So the first part of improving our vulnerability assessment is improving our data collection process. There's an old adage, garbage in, garbage out, which very much applies here. If you have bad data to start out with, then your analysis and reporting are going to be very much affected by that. For instance, if you run a vulnerability scan incorrectly or run it a certain way that doesn't provide you with results, you have a lot of false negatives. When you get to the end result of the assessment, you're going to think that maybe the environment is in good shape when in fact it's not at all. And when we talk about data collection, obviously things like vulnerability scanner results would be a part of that, but this is also including any type of data collection that you do. If you're pulling firewall configs or network device configs, pulling information from Active Directory or another user database or permissions database, any types of manual checks you do, that's all part of the data collection process, and all areas that we can look to improve. Well, how do we improve those things? I'm just going to talk about a couple things today that I think are critical if you really do want to become better at vulnerability assessments. That's knowing your tools that you use in the process of data collection, questioning the results that you get back from the data collection, and create and automate, for lack of a better term there. I'll go into more detail on that. But knowing your tools obviously would include knowing how to use a port scanner, vulnerability scanner, firewall analyzer, whatever type of tools that you're using in your process. But this would also include techniques that you perform manually, and an overall methodology. Knowing your overall methodology, having that down, understanding what pieces of collection you're going to do, what order, what kind of checklists you're going to have, making that all concise and correct. Regarding tools specifically, one thing that's really important to me is that when you're doing a vulnerability assessment, you should be driving that assessment. You should know what data you want to collect, why you want to collect it, and as a result of that, you should, I think, be able to, if you want to, again, take it to the next level, you should be able to manually do anything that you're using a tool to do if you didn't have that tool. What the tool should do is actually augment your process to make you more efficient, make you less prone to human error, able to do things at a larger scale and faster, but they shouldn't replace your brain and you knowing how and what you're doing, if that makes sense. I think it's also important to know kind of what's going on underneath the hood of these things, so not only knowing what it's doing, but the method that it's using to collect data. So you run a vulnerability scan against a Windows workstation to detect vulnerabilities in Adobe Flash Player. So how is it determining what version of Adobe Flash Player is installed? Is it running a remote registry query and looking at a specific string, matching that? Is it looking at a specific file on the file system and looking at the metadata and pulling a string out of that or something? Is it running a SHA-1 checksum against the file and then matching it to a database of known binary files? There's lots of different ways that you can do this. So if you know how the tool is doing that, you're going to be able to much better troubleshoot when you're not getting back results you expect. If you don't know how the tool is doing what it's doing, then you're really at a loss as far as being able to troubleshoot any kind of issues with that. And the way that you learn all this is by testing them, running them in a lab environment, running different configuration options, running against different types of target systems, and tuning them and seeing what the general behavior is, so that when you run in production, which you also learn things as you run in production, but you'll be better prepared to understand what it's doing and why. Another important thing as far as data collection goes is questioning your results. It's very important to test those and verify them. Something as simple as a quick sanity check, running a scan multiple times and comparing those results to see if they match or to see if you get wild discrepancies can be very useful, and it doesn't necessarily take a lot of time, especially if you're just looking at a subset of hosts or devices. If you do see a lot of variation, then you know something's up. If you don't see a lot of variation, then you've got a higher level of assurance that what you're getting back is accurate. Another useful technique is to manually inspect a sampling of the most significant results. So if you've got several machines, again with Adobe Flash Player vulnerability, being able to and say it's an issue on 100 workstations, being able to log into 3 or 4 of those and confirm that that's actually correct, and it's not misinterpreting the data by checking it a different way, can again raise your level of assurance that the data collection is accurate. And the last part, create and automate. Basically, in addition to knowing your tools and questioning your results, also be looking forward and thinking up. Basically, be creative. Think of new ways that you can collect data. What are new types of data that might be useful to identify new vulnerabilities? Completely new methodologies that you can include in your vulnerability assessment. Maybe you're currently looking at active testing against hosts on a network. Maybe you can add a methodology to passively listen to network traffic, either on the internal network or at the perimeter, to see what types of traffic, and being able to identify other potential vulnerabilities that way. And then, of course, being able to create new tools, be that quick scripts or plugins to other tools, or even completely new things. Being able to do that as needed can be extremely valuable. I'd like to just go through a quick example of putting these types of things together. Something we did a little while back was we were performing a discovery assessment of a customer with very large internet-facing IP address ranges. We were trying to see what was accessible from the internet. So pretty straightforward thing we're trying to determine. But it was a very large set of ranges. So we started small. We started with a very small subset of that and ran some Nmap scans to see what we got back. The results mostly look normal, except a few of the hosts have a lot more open ports than what you would normally see. So we run the scan again, maybe a couple times, maybe a couple different ways, and we realized that the results are varying wildly. So in one instance, we've got these ports showing up as open. Another instance, they're showing up as filtered or closed. So there's not a lot of consistency to that. So we start to dig a little bit deeper using nping. Hopefully some of you have heard of the nping. It's part of the Nmap suite. You can send raw packets to an IP address and manipulate them and see what types of responses you get. And we're able to determine that there's some device in line. So we're over here, and the server we're trying to scan is over here. There's a device in the middle somewhere that's doing what's sometimes known as delayed binding behavior, where it will, instead of allowing the packet to go all the way through, it starts to respond on behalf of that server that you're trying to connect to. So it's going to go ahead and open that TCP connection between you and it and kind of proxy it, and then it may or may not send additional data back to that end server based on whether it's open or not and what's going on. But this can really affect the results of a port scan. And moreover, it's not doing it all the time. So sometimes it will respond with that delayed binding behavior. It will try to open. You send a TCP send packet, it sends back a send ACK. But sometimes you'll get a reset or you'll get nothing. So it's only responding some of the time. We never completely ruled out why this was happening. One theory was that there were multiple routes that were being traversed. Sometimes a packet would take one versus the other, and the device that was doing the behavior was configured on this one, but maybe not the same on the other route. So regardless, it was making port scanning very difficult. So what we did, we first determined that the packets that it was sending back had a very specific TTL value, and they also had a very specific TCP window scale option in the TCP header. So based on that kind of fingerprint, we could tell whether a packet was coming back from that device or it was what we assumed to be legitimate. Then, if you're familiar with Nmap, there's an ACK scan which sends TCP ACK packets. These are completely useless for determining open or closed ports, but it will allow you to very efficiently map out where firewalls are blocking certain traffic. So the end result that we were able to make work for us was running an nmap ACK scan first of all, ruling out like 90% of the ports as being blocked by the firewall, and then ones that weren't blocked, we wrote a custom nmap script with the NSE nmap scripting engine, and it would probe each of those ports multiple times and discard any packet that came back that matched that fingerprint for the delayed binding. So we tried a number of times, and if we got back something else, then we determined if the port was open or closed based on that response. Or if we never got anything back, we just move on and consider it, not open. And I'm sure this wasn't 100% accurate, but it was night and day compared to the results that we were initially getting. So that's just one example of knowing your tools, what the tools are capable of, questioning your results, not assuming blindly that what you get back is accurate, and also being a little bit creative, writing some custom code to compensate for the current issue at hand, and being able to scan through those issues. I'm probably not going to get through everything, but we'll see how far we make it. The data analysis is the second part of the vulnerability assessment, and this is a part where if your title is security analyst, this is where you can kind of show some of your value by performing the analysis. So this is a good place to improve yourself if you want to show your value, I guess. How do we improve in this area? One thing that I think is really useful is doing some exploratory analysis, which is my term for just looking at the data in a lot of different ways. So taking the raw data, looking at it by host, looking at it by vulnerability, looking at it by every different metric that seems interesting, and not necessarily following a prescribed methodology. I mean, you want to have a set methodology, but also taking a little bit of time just to look for what's different or what you haven't seen before, how you can continually improve what you understand about the data, and so on and so forth. And that's kind of what the tool that I've started putting together is geared towards, doing that analysis. Show me, all the hosts that are missing some particular Java patch, or just show me the distribution of Java versions in the environment. Things like that. Consolidating common results is incredibly useful. If you've seen something 100 times, then kind of just lumping that all together, setting it aside, and looking for other things that are more interesting or more unique to the environment that you're looking at can be very valuable, because you've got a limited amount of time in any type of engagement, or if you're doing vulnerability analysis internally, you're still limited on time, so you want to make the most efficient use of that time. Oh, got an ice cube. And lastly, it's always good to find ways to reduce false positives. As everyone knows, all the tools have false positives, regardless of what is said, and being able to identify those is always going to increase the value of the data analysis. Another call it a dirty trick, I guess, that I like to use is running multiple tools and then cross-validating the data. So if you've got, say, for example, you've got two different vulnerability scanning tools, you can run a scan against the same set of hosts with both of them and see what results each of them provides back. Where are they the same? Where do they differ? And initially, when you do something like this, you're going to learn a lot more about the tools themselves in some ways than the environment that you're looking at least initially. But then often you can use that as a further method of ruling out potential false positives or making them less likely. If multiple tools report a particular issue on a particular host, then it's a lot more likely that that is actually valid and not a false positive. And that's something that I can do with this tool. So I'm going to switch over and do a few things here. Can everybody see that okay? I'm going to have to turn around because it's only up here. It's not on my screen. So this tool has several different commands built in right now. Not all of them work, but they're getting there, and there will be more added. It supports Nmap, Nessus, Nexpose, and Qualys XML formats right now. I'm sure more will come. I just want to highlight the diff command for the purposes of this talk, just to give a little bit of overview of what can be done. So we've got several types of diffs we can do, and note that this will actually do diffs between different products. So if you've got an output from one tool and output from a completely different tool, as long as they're supported, the goal is to be able to compare and contrast those regardless of what specific tool it was. So I've got a sample Nessus scan with XML output, and also a sample scan from Nexpose that I'm going to be using to demo a few types of commands. So first we'll run the host diff. So this will tell you actually, let me run it again up here so it's a little bit higher. It'll tell you, it'll count up how many hosts, and right now it's matching just by IP address, how many hosts the first scan found only, how many hosts that only the second scan found, and how many hosts that both of them found. And you can see already we've got a little bit of discrepancy here. There was 488 that both of them found, but there were 219 that only one of them found, and there were 68 that only another one of them found. And there's a lot of reasons for these discrepancies. One of which I'm sure is that my tool is not always doing everything correctly. But there's also a lot of differences based on how the tools are configured and how they report different issues. So, like I said, you'll learn some more things about the tools. Another type of diff that we'll do is a Microsoft hotfix. So it'll list out all the hotfixes that were found missing on a host, and the first column there is hosts that were uniquely found by the first tool. The far right column are ones that were uniquely found by the second, and the middle column is ones that were found by both. So again, you're seeing a lot of discrepancy here in just the counts. And there's a verbose mode that I'll run to actually list out the specific IP addresses. So if the arrow is pointing left, then it was only found by the first report that you gave it, and if it's pointing right, it was only found by the second. And if it's equals, then both of them found it for that particular hotfix. And then let's just do a... Let me find out my history actually. There we go. So we can just filter out what was found in common. Like I was saying, the dirty trick to just assume that some of these are accurate and only look at the other ones in more validation. So where's 08067? So there's three hosts that both tools found appeared to be vulnerable to the MS08067 configure vulnerability. And there's a lot more that you can do with it, even in its somewhat alpha broken state. So feel free to download it and play around with it. only got a couple minutes left, so I'm just going to jump through. Unfortunately, the reporting and communication I feel is one of the most important areas to focus on improving, because I think communication skills are at least as valuable as technical skills, and that's one area where I feel like I'm often insufficient in. And your skill ceiling is often limited by the minimum of those. So if you've got really high technical skills but low communication skills, then your overall ability to perform any kind of security assessment is going to be limited by that. Skip through this stuff. Just to close out, the big picture that I want to get across today is don't settle for the status quo. Even if there's the field of vulnerability assessment is not necessarily as exciting in some ways as doing penetration testing or looking at the latest 0-day or post-exploitation module, but it doesn't mean it necessarily has to be stale. Just look for ways that you can find to improve that, to improve your processes and grow your abilities. And if you learn something useful or build something cool, then feel free to share back with the community. I'm sure that many of you can come up with some stuff that's much cooler than what I've presented today. So, any questions? Are we at time? Okay. So feel free to grab me afterwards or at any point during the con if you want to talk or have any questions for me. Thanks for your time.